So, good evening to everyone. So, welcome to ACE Engineering Academy as well as ACE Online. So, we know that ACE Engineering Academy as well as ACE Online is conducting GATE 2026 Core Booster series in order to help the students. So, as part of this series of classes, today we are going to start computer networks related discussion. So, as part of that series, as we planned, only NAT type of questions and MSQ kind of questions. So, let us see the first question, which is based on a concept of layering. So, if you look into this question, concept of layering, so you know at the center side the data transmission is in top down approach. So, while it is traveling from top to bottom, the headers are being added at the center side, right? So, if you are having that particular point in mind, you can easily answer this particular question. So, can you tell me what is the answer for this question? So, the question statement I am going through here. A 1000-byte message is sent over the network using a protocol stack with HTTP, TCP, IP and Ethernet. Each protocol header is 20 bytes long. What is the percentage of the network bandwidth on the wire that is used for message data? Only data, we are speaking about data, okay. So, what is the percentage of the network bandwidth on the wire is used for message data? So, we are expecting here NAT type of question. So, this is NAT. So, try to solve this question. So, if you consider this question, so in parallel to me, you also can make an attempt to solve this question. It is given that the message size is 1000 bytes, right? So, what I can write? 1000 bytes of message you have. And this message is sent over the network using a protocol stack with HTTP, TCP, IP and Ethernet. So, what does it mean? You know that this is what your sender system. At the sender system, you are having application layer, you are having transport layer. If I speak about TCP IP reference model, transport layer, and then I am having internet layer, and after that I am having physical layer plus data link layer combination, which is your host to network layer. So, like this you are having 4 layers here, right? HTTP is part of which layer? Application layer. TCP is part of which layer? Transport layer. IP is part of which layer? Internet layer. And as part of this physical layer and network layer, we are having this technology. What is the technology? Ethernet, right? We can call this is a technology, and these are all the protocols. So, now you know that now this is the message, this message is having, this is the sender, the sender is having 1000 bytes of message. So, this 1000 bytes of message is been traveling in top down approach. So, when it is traveling in top down approach, obviously at each layer we are appending the header. How many bytes of header we are appending? 20 bytes of header. So, that to this 1000 bytes at this application layer 20 bytes are being added. Now, this is coming to what? 1000 plus 20, and then when it comes to transport layer, again you are appending what? This 1020 bytes is part of your data field, and for this 20 bytes of IP header can be added. TCP header can be added here, TCP, right? TCP header can be added. And then at the network layer, means it at the internet layer, again totally this is comes under your data portion of your IP. So, it means it is coming to what? So, 1040, right? So, this is what? 1040. So, if I erase this part, so verify now, you will get the clarity. So at the sender side, this is what your message. At application layer, you have appended 20 bytes of header. HTTP protocol is appending 20 bytes of header. And now this is entirely where it is getting encapsulated. It is getting encapsulated into TCP data field, and TCP header is been added. Now this is your TCP message which is having 1040. And this 1040 TCP message is coming into IP portion, IP data portion. So this is what your data portion, 1040. For this 20 bytes of header you are appending. And then this whole message is coming to this physical layer plus data link layer. Here also what you are having header, you are appending header. What is the bytes of header you are appending? So you know that as part of the physical layer, you are having preamble and SFD. These are the kinds of fields we are having as physical layer headers we consider. So those are also, as the question is mentioned, each protocol header is 20 bytes. Here also 20 bytes of header can be added. And what is the data portion here? 1060. So overall, what is the size of the message that is getting placed onto channel? What is the size of the message that is getting placed onto the channel? 1080 bytes of data. 1080 bytes. 1080 bytes of message is being placed onto the channel. So this 1080 includes what? Message means your data plus headers. But the question is asking about what is the percentage of the network bandwidth on the wire that is used for sending the message data, only message data. So what is the size of the message? 1000 bytes. So 1000 by 1080, this much percentage of network bandwidth is being used to send this data. So if you evaluate this expression, you will get the answer here. So but this is what expression here, 1000 by 1080. This much network bandwidth is being used, this much percentage of the network bandwidth is used on the wire for sending the data. So I hope you are clear with this question and its corresponding explanation. Okay, all right. So let's move to the next question. Yes. So this is the question we are choosing from network layer, and it is an MSQ kind of question. So the question is asking about what addresses? Valid addresses. So what is the meaning of valid? The meaning of valid is your host ID portion should not be all zeros. Your host ID portion should not be all ones. Host ID portion should not be all ones, and host ID portion should not be all zeros. Right? So this is what your valid concept. So now the question is clearly mentioned. This is what your IP address. So 205.222. So sorry for the interruption. Because of the power failure, we have got the interruption in our session. So coming to this same question statement. So it is given IP address as well as it is given subnet mask address. So when you have IP address and subnet mask address, what you can calculate? You can find out subnetwork address, right? So if you calculate the subnetwork address, So the mask byte is 255, set the corresponding byte of an IP address to the result. Mask byte is 255, set the corresponding byte of an IP address to the result. Again mask byte is 255, set the corresponding byte of an IP address to the result. But this is the mask byte which is neither 0 nor 255. So that we should perform the logical AND operation between these two bytes. But what is the last byte value you are getting? 0. So this is what your subnetwork address. Now what you have to do, you have to divide this subnetwork address into 3 parts. So 205.222.5, this is comes under your network ID because the given class is class C, right? Then this, after defining the network ID, whatever the 0 we are having, this 0 we are writing in terms of binary. Okay. So then after NID portion is being defined, we required SID portion. So coming to the SID portion, as SID portion I can get from subnet mask address. So what is the subnet mask address here? 255, 255, 255, 248. It means 24 plus 5, 29 ones we are having. How many ones are extra? 5 ones are extra. So those 5 ones I can see in the last byte. So these are the 5 ones which are extra to me, correct? So for these 5 ones, what are the corresponding 5 zeros or 5 bits I am having? These are the 5 bits or not? So then this is coming to my SID portion, and these 3 bits are comes under my HID portion. So overall, this is NID, this is SID, and this is HID. So HID portion is what? Last 3 bits. So now if you check here 17, if I write into binary, so we need to think about only the last byte because the given IP address belongs to class C. So that first 3 bytes are, for all IP addresses, first 3 bytes are NID portion. Then 17, how can I write 17 in terms of 8 bit? Let's say, so 0001, 001. So this is what your 17. So among these 17, these 5 bits are what? SID portion, and these 3 bits are what? HID portion. Is your HID portion contains all zeros or all ones? No. So means this is going to be valid IP address. Then coming to 18, if you consider 18 if you consider, right? So coming to the 18, 00010, this is 16, and this I can write as 2, which is 18. So verify, these are the bits that are comes under your SID, and these 3 bits are your HID. HID portion contains not all zeros, not all ones, so that this is also valid. Then coming to 16, if you write, how can I write 16? This is what your 16. So this is your SID portion, and this is what your HID portion. HID portion contains all zeros. So since it is a HID portion is all zeros, this particular IP address is invalid IP address. Then we are having 19. So 16 plus 3. How can I write 3? This is the way how I can write 3. So now this is what your SID portion, and this is what your HID portion. HID portion contains not all zeros, not all ones, so that this is also valid. Then coming to 31. So 0, 0, 0, 5 times of 1. This is what your 31. So if you see, first 5 bits are your SID portion, already your NID portion is here. Now these are the 3 bits which are belongs to your HID portion, right? These are all last 3 bits are your HID portion. HID portion contains all ones, means this is also not valid. So as the question is asking about valid host addresses, 1, 2 and 3 means 1, 2 and 4, 1, 2, 4, right? 1, 2 and 4 are valid host addresses. Are you clear with this? So this is the way how you can define this particular question. So and mind this particular question I am doing a slight modification, that which address are valid host addresses with respect to any subnet. With respect to any subnet. So that is what my exact question. Then what is the answer for this question? 1, 2, 4 is the answer for this question. Okay, right. So then I hope you are clear with the explanation of this question, right? So now we are moving to next question. So look at this question. Again, this is based on your network layer concept. A TCP message consisting of 2100 bytes is passed to IP for delivery across two networks. The first network can carry a maximum payload of 600 bytes per frame, and the second network can carry a maximum payload of 400 bytes per frame, excluding network overhead. Assuming that the IP overhead per packet is 20 bytes, what is the total IP overhead in the second network for this transmission? Okay, so you need to forward this particular 2100 bytes, and that too it is clearly mentioned. The TCP message consisting of 2100 bytes is passed to IP delivery across two networks. The first network can carry what? Maximum payload of 600. So the TCP message contains 2100 bytes of data. 2100 bytes of data it is having. Okay, so 2100 bytes of data is passed to IP for delivery across the two networks. So the first network can carry maximum payload of 600. So this is payload. Payload means what? Data portion. So look at, this is what your first network MTU. What is the first network MTU? And data portion only we are considering 600. Then what is the second network MTU? It is also having maximum payload of 400. Maximum payload of 400. Right? So the question is clearly mentioning we are excluding the network overhead. It means the 20 bytes of header we are not considering anywhere of these networks. So now the TCP message is having 2100. This is also data. So now this 2100, am I able to pass from this end to this end at a time? No. Then 2100 divided by 600. It means first I can send 600, this is one fragment. Again I can send 600, again one fragment. This is only data portion. Correct? So this is only data portion. So verify this data portion, is it divisible by 8 or not? So 600 is divided by 8 if I do. So 600 divided by 8 if I do. Yes, it is divisible by 8. So that's why we are considering 600 and 600. So up to now, two fragments are being created from 2100. And one more fragment also I can create, another 600. So this 2100 is being splitted so far. How many fragments? 3 fragments. Up to now it is 1800. And the last one we are having just 300. So total on this network you are having 4 number of what? Fragments. So now this 600, am I able to pass a test edge onto this network? No. But this can be, when I pass this 600 via this MTU of 400, how many fragments it can create? It can create 2 fragments, right? It can create 2 fragments. What are the 2 fragments? One is 400, other one is 200. So similarly, this is also can create another 2 fragments like 400 and 200. And this is also can create another 2 fragments. What are the 2 fragments? 400 and 200. Then this last one, a test edge I can forward because it is less than this MTU, correct? So then it is coming to just 300. It is coming to just 300. Because the 300 is less than this MTU. So overall, if you see how many fragments you are having, 1, 2, 3, 4, 5, 6 and 7. So 7 fragments are there on the second network. This is what your network 2, this is what your network 1. Total, how many fragments you are having on your second network? 7 fragments. So the first option, if you see, number of fragments on the second network is 6, which is false, right? But number of fragments on the second network is 7, which is correct. Then the total overhead on the second network. So total overhead in the sense, overhead is what? Header bytes. You know that as it is IP, for every fragment you are appending how many bytes of header? 20 bytes of header. So 20, 20, 20 if you add. So then total how many bytes, how many times of header you have added? 7 times, because you are having 7 fragments. So every fragment is having 20 bytes of overhead. So that what is the total overhead you are having? 7 into 20. So which is coming to 140. So 140 bytes is the total overhead. This is also correct, but 120 is not correct. So overall, if you see, option B and option D is the answer for this question. Okay. So I hope you are clear with this explanation. Right. So now we are moving to next question. So what is the next question that we are having? This is the next question we are having based on the same network layer, but this time the concept is routing based. For the network given in the figure below, the routing tables of the 4 nodes A, E, D and G are shown. Suppose that F has estimated its delays to its neighbors A, E, D and G as 8, 10, 12 and 6 milliseconds respectively, and update its routing table using the distance vector routing technique. So here the routing tables are being given. This is the routing table for A, this is the routing table for D, this is the routing table for E, this is the routing table for G. So we need to find out the routing table for F, right? We need to find out the routing table for F. So F, A, B, C, D, E, F, right? A, B, C, D, E, F and G, right? So if you see here routing table of A to A it is 0. If you see D here, D to D it is 0. If you see here E, routing table E to E it is 0. Then routing table G, if you check G to G 0. So similarly F to F it is 0. Then it is already calculated to its neighbors. F to A, what is the cost it is having? 8. F to E, what is the cost it is having? F to E it is having 10. F to D it is having what? 12. And F to G it is having 6. So it is enough to find out only what? B and C. So how can I write B? How can I reach to B from F? So F to B. So I can reach first A and then B, F to A and then A to B. F to A, what is the cost I am having? 8 plus A to B, if you check in the routing table it is 40. So that 48. This is one cost. Then I can travel from F to D and then D to B. F to D, if you check it is 12 plus D to B, if you check D to B, where is the D routing table? Yes, here 8. So which is 20. And remaining all, if you check not directly, like I have to travel to F to E and then E to C and then C to A and then A to B, or else F to G and then G to D and then D to B. But these are the best paths here. So among these two, which is the shortest one? 20. So that 20 can be for B, right? Then coming to C, how can I travel to C? So F to C. First I can travel F to A and then A to C. What is the F to A? F to A, it is 8 plus A to C, if you check 14, which is 22. Then F to E and then E to C. F to E, it is measured as 10. Then E to C, if you check 7, which is 17. Then F to D and then D to C. F to D, it is 12. And then D to C, which is 30, which is coming to 42. So among these paths, which is the shortest one? This is the shortest one. So it should be 17. So this is the way how you can answer this question. Now look at the question statements. So which of the following is are true with respect to routing table of F? The distance from F to C is stored as 28. F to C 28. Is it C? Is it correct? F to C. F to C, it is stored as 17 but not 28. So that this is false. Then the next hop router for a packet from F to B is D. F to B. F to B. What is the shortest cost? 20. What is the next hop? D. So it is speaking about that one only or not? Yes, F2B it is D. Yes, it is true. Then the distance from F to B will be stored as 30. F2B is actually storing as 20 but not 30. This is false. Then the next hop router for a packet from F to C is E. F to C is E. Yes, because we are having 17. Yes, E. So this is true. So that what is the answer for this question? As the question is asking about true, B and D. Okay, right. So then coming to the next question. So I hope you are following, right? Look at this question. This is another MSQ question. TCP reacts to the congestion by reducing the center window size. So you need to find out what? False statement. Mind this. TCP reacts to the congestion by reducing the center window size. This is option A. The size of the receiver advertised window never changes during the course of the TCP connection. In option C, the TCP's slow start phase, the transmitter's transmission rate is slower than the TCP's relative increase phase. Option D, the packets of the same session may be routed through different paths in TCP. So if you check here, TCP reacts to the congestion by reducing the center window size. Is it correct or not? Yes, it is true. Because whenever there is a congestion is occurred, it means it is reaching to the congestion threshold. Additive increase phase we are considering as what? Congestion avoidance, and multiplicative decrease phase we are considering as congestion detection. So when this congestion detection is being occurred, obviously we are setting the congestion threshold value to the current congestion window, I mean half of the current congestion window, and then we are dropping the congestion window size to 1, and then again we are starting slow start phase. That is what the meaning of reacts to the congestion by reducing the center window size, which is true. Then the size of the receiver advertised window. See, this is what the question, this is what the line, receiver advertised window never changes during the course of the TCP connection. So actually it is speaking about receiver's advertised window. Receiver's advertised window can be changed, but what cannot be changed? Receiver's buffers cannot be changed. Receiver buffer cannot be changed, right? So generally what is going on? Receiver's buffer cannot be changed, but this can be changed. But the question is mentioned never be changes. So that is why this is false. Right. So now coming to what is that? In TCP's slow start phase, the transmitter's transmission rate is slower than TCP's advertised window. This is also false. Reason, in slow start phase, your TCP window is having exponential growth, but here it is mentioned slower. In relative increase phase, you are having what? Linear growth, but in slow start phase, you are having exponential. It is very faster, but the question is mentioned it is slower. That's why it is false. Packets of the same session may be routed through different paths in the TCP. So this is, I mean, packets of the same session may be routed through different paths in TCP, which is a true statement. How it is true? You can say, this is what your network layer having IP header here, and this is what the data portion. This is your network layer. At transport layer, you are having TCP here. You know that at the center side, the data transmission is in top-down approach. It means the TCP comes into data portion of IP. This is what your IP. And you know IP is a connectionless protocol, and since it is connectionless, it can travel in multiple paths. If your IP is traveling in multiple paths, inside the IP what you have? TCP. Obviously TCP also can travel in different paths. So that what is the answer for this question? True. I mean, what is the option D status? True. So overall, what is the false statements? B and C are the false statements. So B and C is the answer for this question. Okay, right. So now let us check the next question. Yes. So this is about IP datagram. So in order to solve this kind of questions, we need to have thorough idea about the whole IPv4 datagram header format. So let the size of the data is x bytes and the length of the header is y bytes, then what is the value of x plus y? It means it is speaking about the total length, right? So verify, first 4 bits are your version field, Next 4 bits are your HELN field. So HELN field is what? 5 in hexadecimal. If you convert this into decimal, it is coming to 5 only. Then what is your header length? 5 into 4 bytes. HELN into 4 bytes, which is 20 bytes. Okay. Then the next 2 digits comes under TOS, and the next 4, okay, the next 4 is what? Your total length. Okay. So total length field, what is the value you are having? Total length is 30, it is 16 bit, right? So 16 bit. So then 0028 in hexadecimal. So then how can I write this one? 8 into 16 power 0 plus 2 into 16 power 1. So 32 plus 8, which is 40. So total length is your 40. So let the size of the data is x bytes and length of the header is y. Then what is x plus y? X is what? Data portion, data length, plus y is what? Header, right? Y is header length. So indirectly it is asking about what? Total length. So if for example, if I mention, let the size of the total length field, okay, total length field, or else you can say total length field is what? For example, if I do no changes here, total length field what? You are getting 40 bytes. 40 bytes, okay. So you are having 40 bytes. And you know total length is equals to header length plus data length. So which is given 40 bytes. Header length is what? Which is 20 bytes. So then 40 bytes minus 20 bytes, you are getting 20 bytes. So now look at header length is, the question is clearly mentioned, the length of the header is y. So this is what your y. And now the data length is what? 20 bytes. 20 bytes is what? This is what your x. Let the size of the data is x bytes. Then the question is asking about the value of x plus y. X plus y is what? Again it is 20 plus 20, 40 bytes. Means indirectly it is asking you the total length value. So what is the total length value here? 40 bytes. Okay. So 40 bytes is the answer for this question. I hope you are clear with this. Next. Look at this question. If you consider this, consider 3 networks A, B, C respectively. The host X sends the data size of 1480 without 20 bytes of header to the host Y. Okay. So this is what your host X. This is what your host X. And this is what your host Y. The network ABC are having MTUs of 1500 bytes, 200 bytes and 400 bytes. Okay. So this is having here 1500, this is having 200 and 400. Okay. So network B is having 200, network C is having 400. MTU includes header size. The size of the header is 20 bytes. Okay. So all these MTUs are having header bytes. The size of the header is 20 bytes. Then the total length of the last fragment that can be received by host Y is dash. So verify this question. If you consider this question without 20 bytes of header, without 20 bytes of header to the host Y, what is the size of the data you are sending? 1480 bytes. So it means here this is sending 1480 bytes of data from here to here. So you know that this is 1500 bytes. So 1500 bytes, how you can write? 1480 plus 20, because the question is clearly mentioned MTU includes header size. So now 1480 bytes of data you are having here. 1480 bytes of data you are having. So and this network is able to allow total 1400 to this side or not? Yes, total 1400 can be forwarded to this particular one. 1480 can be forwarded to this one because this network is allowing 1480 bytes of data. This is your header. Then 200 if you consider 200, this is I can divide like 180 plus 20, but 180 is it divisible by 20? Verify. I hope so. 180 is not divisible by 8. So 180 divisible by divided by 8. If you see, it is not divisible. Then what is the nearest value that I have to choose? 176 I have to choose. Yes. So 176 I have to choose. Means this 1480 I am going to divided by 176. So 1480 divided by 176 if I do, I am getting 8.4, means 9 fragments I am going to have. 9 fragments, right? So here this network is allowing this 1480 onto this network like 9 fragments. Out of 9 fragments, 8 fragments are having full. What is a full? 8 into 176. Okay, 176. So 8 into 176 if I consider. What is that? 1408. 1408. 1408 plus 1408 minus 1480 if I consider. So 1480 minus 1408. So 72. So the 9th fragment, last fragment will have 72 bytes. Now these 9th fragment, all these 9 fragments, what you are doing, you are passing through this network, but this network is allowing 400 bytes of network, 400 bytes of MTU. This 400 you can divide like 380 plus 20. But 380 is it divisible by your 8? Please verify. 380 is divisible by 8? No. Then what should I consider? I should consider 376, I hope so, which is divisible by 8. Yes, 376. So this should be considered as 376, and here it is 176. Correct? So then all these 176 and 72, is it less than this 376 or not? Yes. So then what will happen? The last fragment total length means header length plus data length. Header is what? 20 bytes and data portion is 72 bytes. Total, how many bytes of total length you are having? 92 bytes of data. So that is what the answer for this question. Okay. So I hope you are clear with this. Right. So next, coming to this question. So consider an IP address 12.16.4.75/22. Which of the following is true about the given IP address? So the question is asking about subnetwork address. So subnetwork address in the sense your first address. So simply I have to find out first address here. To find out the first address, what should I do? I should set 32 minus 22 number of last 10 bits. I need to set to all zeros. So 12.16.000.0100, this is what your 4, 75, this is 64, 64 plus 11, this is what your 11. So this is your 75 slash 22. Last 10 bits you need to set to all zeros. If you set last 10 bits all zeros, then you are getting 12.16.4.0 only. So means this is a subnetwork address which is true. So the question is asking about true, no? So this is true only. Then what is the subnet? The subnet mask address is 255.255.248.0. 255.255.248.0. So mask is what here? 22. So 22 in the sense 22 ones are there. 22 ones in the sense 255, 8, 255, 8, 16, and then 16 plus 6, 00 and 80. Then it is going to be 255, 255, 252.0. But here it is given 248.0, which is wrong. So this should be according to this mask, it is 255.255.252.0. Then the direct broadcast address of the subnet is 12.16.4.254. Direct broadcast address means last address, right? It is speaking about last address. So consider this last address. Last 10 bits I need to set to all ones. So here I can set ones, and then here I can set all ones. Then what will happen? So 12.16.7 it is going to be 7. 255. But here it is getting 12.16.4.254. But actually broadcast address is what? Last address. Last address is what? All ones. Host ID portion should contain all ones here, right? So, but here it is not like that. So that's why this is false. Then valid last host address of the subnet is 12.16.4.254. Is it correct? No. Reason? The valid last host address. So if it is the last address, 7.255 is the last address. So before this, what is the address you are going to have? This is 7.255. So 12.16.7.255 is your last address. So before this, what is the address that you are having? Before this, you can have, you can say 7.254 you can have. But here it is given 4.254, which is wrong. So overall, the question is asking about true. Okay. So direct broadcast address is what? So 12.16.4.255. Last address, if you consider 12.16. This is 4. So last 10 bits I need to set to all ones, right? So all 10 bits I have set to 1, then it is coming to 7.255. So consider this question as false. Then MSQ, if you consider, this is BCD is the answer for this. So these three are false here. The direct broadcast address of the subnet is 12.16.7.255, but not 4.254. And the valid last host address of the subnet is this one. So 7.254 is the last host address. Okay. So BCD is the answer. First question, first statement is true here. Then look at this question. Efficiency is given 100%. So if efficiency is given as 100%, then what is the condition you have? W is equals to 1 plus 2A in sliding window. Bandwidth is given 30 kbps. Frame size is 60 bytes. So from these two you can calculate Tx, which is L by B. So it is 60 into 8 by 30 into 10 power 3. So So 60 into 8 is 480 by 30. So 480 by 30, if I calculate, I am getting 16 milliseconds. So Tx is 16 milliseconds. Propagation delay is Tp directly given 200 milliseconds. Then what I can calculate? A is equals to Tp by Tx. Tp is 200 milliseconds by Tx is what? 16 milliseconds. So 200 by 16. If I do, I am getting 12.5. Then substitute this A value here. So W is equals to 1 plus 2 into 12.5, which is I am getting 26. But this is a selected repeat sliding window. So in selected repeat sliding window, what is your W? Half of the 2 power n. So half of 2 power n is equals to 26. Then 2 power n is equals to what? 52. Then how many bits are needed to have 52 frames in your window? In the sense 6 bits. So 6 bits is the answer for this question. Okay. So like this we can have several questions to solve. Because of the time constraint, we may not able to continue the session, but there are so many questions which we have planned to discuss in this particular session. So I hope so. Based on these questions, you can expect questions in your GATE 2026. This kind of model questions can be expected in GATE 2026. So I hope this session is helpful to you, right? Thank you. Have a great day.